rise. Announcing the arrival of Professor Dr. Rafina Yasmin Osman, the Associate Vice Chancellor, Industry and Community Networks, University of Malaysia, and Professor Dr. Lu Kiong, the Department of Artificial Intelligence, Faculty of Computer Science and Technology, University of Malaysia. Guests are requested to remain standing for the national anthem and official theme song. And please be seated. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon. Professor Dr. Rafina Yasmin Osman, the Associate Vice Chancellor of Industry and Community Networks. Professor Dr. Abdullah, the Dean, Faculty of Computer Science and Information Technology. Mr. Roman Lozov, the Deputy Representative Office of the Russian Federation. Mr. Lau King Hui, Group Managing Director, Sasbadi Learning Solutions Sdn Bhd. Datuk Vimi Yap Miling, and Mr. Lee Cheong Lung, Founder and CEO of 6Biz Sdn Bhd. Professor Dr. Lu Kiong, Management of Faculty of Computer Science and Technology, University of Malaya, distinguished guests and ladies and gentlemen. Welcome to the inaugural lecture by Professor Dr. Lu Chu Kiong from the Department of Artificial Intelligence, Faculty of Science and Technology, University of Malaya. Today, Prof. Lu is going to deliver his lecture entitled Continual Learning with Neural Networks, Short Overview and Challenges. So without further delay, I would like to invite Professor Dr. Rofina Yasmin Osman to chair the lecture and to formally introduce Professor Dr. Lu Chu Kiong. Please be invited.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera, selamat tengah hari dan selamat datang ke acara yang gemilang ini, iaitu Syarahan Perdana oleh Profesor Lu Chu Kiong. Yang berbahagia Profesor Dr. Abriza Abdullah, Dekan Fakulti Sains Komputer dan Teknologi Maklumat, para hadirin daripada industri yang dihormati, timbalan-timbalan dekan, ketua-ketua jabatan, profesor-profesor, pensyarah-pensyarah dan pelajar yang dikasihi tuan-tuan dan puan-puan sekalian. Selamat datang diucapkan kepada semua hadirin yang dihormati. Bagi pihak Universiti Malaya, saya mengalu-alukan kehadiran tuan-puan dan amat gembira berada bersama di Fakulti Sains Komputer dan Teknologi Maklumat sempena syarahan perdana Profesor Dr. Lu Chu Kiong sebagai Profesor di Universiti Malaya. Dengan izin, saya akan teruskan ucapan saya dalam bahasa Inggeris. Ladies and gentlemen, honored guests, it gives me great pleasure to extend to all of you a very warm welcome. It is indeed an honor for me, on behalf of the University of Malaya, to be able to chair this afternoon's inaugural lecture by Professor Dr. Lu Chu Kiong, Professor of the University of Malaya. To quote an ancient proverb, if you are planning for a year, sow rice. If you are planning for a decade, plant trees. And if you are planning for a lifetime, educate the people. And as Nelson Mandela once said, education is the most powerful weapon which you can use to advance the world, to change the world. So today, we are proud to celebrate an educator, a professor, and I'm proud to say, an alumnus of the University of Malaya. Please allow me to introduce Professor Dr. Lu Chu Kiong. Professor Dr. Lu Chu Kiong completed his Bachelor of Mechanical Engineering degree with honors at the University of Malaya in 1996. After completing his bachelor's degree, he began his career as a systems engineer at semiconductor engineering manufacturer Sdn Bhd in Penang in 1996. He then received his PhD degree at the University of Science Malaysia in 2004, specializing in neurorobotics. He thus began his academic career as a lecturer at the Faculty of Engineering and Technology, Multimedia University. He was promoted to senior lecturer in 2008 and then to associate professor very quickly in 2010. He served as the Dean of the Faculty of Information Science and Technology, Multimedia University in shortly afterwards. And in 2011, a year later, he was appointed as a full professor at the Department of Artificial Intelligence, Faculty of Computer Science and Information Technology, University of Malaya. His main research interests are neuroscience-inspired machine intelligence. He has led numerous research projects as a principal investigator for many international funded projects, including those funded by Intel, AOARD, Sumitomo Foundation, UAE-UAUA Joint Research, and Interfaculty International Initiative in Computational Systems Care, Tokyo Metropolitan University. He has also contributed to many other groups, such as Smart Wearable Implantable Medical Devices under the CREST Fund. From these research activities, he has published more than 200 peer-reviewed journal and conference papers on neurorobotics and machine intelligence. Prof. Lu is also the recipient of many international awards, including the JSPS Fellowship Award from Japan, the George Forster Fellowship Award recently from Hubble Foundation in Germany. He has been a visiting professor of the University of Prefectural Osaka University, Japan, and King Mongkut's Institute of Technology in Lat Krabang, Thailand. Apart from his academic responsibility, he has been called upon as expert panel by numerous national bodies, including those at the Ministry of Education Malaysia, the Academy of Sciences Malaysia, and the Ministry of Energy, Science, Technology, Environment and Climate Change, MASTEC, or formerly known as MOSTI. He is also a reviewer of several international technical journals, which includes the highly ranked IEEE Transactions on Neural Networks and Learning Systems. It was certainly my pleasure to have had the acquaintance and the chance to work quite closely with Professor Lu when he was appointed in 2013 as the Deputy Director of the University of Malaya Center of Innovation and Commercialization, heading the IP portfolio at the department. Under his stewardship, with the support of UMCIC team, University of Malaya won the Silver Award as the organization with the best IP management in Malaysia under the Anugerah Harta Intelek Negara 2017, awarded by the Malaysian IPO Office. Prof. Lu is certainly a multi-talented professor. Amongst his many achievements, and I don't know where he finds time for this, Prof. Lu is also a founder of a very successful UM spin-off company, UM Connected Healthcare, or UMCH Sendirian Berhad. The UMCH company is an incubator company specializing in the innovative connected fitness, wellness, and healthcare technology solutions nurtured by research output of the University of Malaya. The medical AI platform it provides has been developed in collaboration with the Primary Care Medicine Department and Social Preventive Medicine Department of the University of Malaya Medical Center, or UMMC, to provide industry-accredited remote health monitoring services to its customers. The company has obtained many awards, such as Special and Gold Award in the World Invention Innovation Contest 2015, the Star Business Outstanding Awards 2015, and the Rice Bowl Startup Awards, Best of Life Science and MedTech, which is a regional ASEAN level award. With that very brief introduction, and there's a lot more to this man, I can tell you that, I'm sure we would like to hear from the man himself. On that note, I would like to invite Professor Dr. Lu Chu Kiong to present his lecture entitled Continual Learning with Neural Networks, a short overview and its challenges. Prof, the floor is yours.
Thank you, Prof. Rofina, for the opening speech. We shall now continue with the main event. Please be invited Prof. Dr. Lu Chu Kiong to deliver his inaugural speech. Please be invited.
Thank you, Dr. Asno. Thank you very much, Professor Dr. Rofina Yasmin, for the very, very nice introduction for me. A very good afternoon to also Professor Dr. Abriza Abdullah, the Dean of Faculty of Computer Science and Information Technology. Mr. Lau Kim Hui, Group Managing Director of Saspadi Learning Solutions Sendirian Berhad. Dato Vimi Yap Mei Ling and Mr. Lee Chong Lung, founder and CEO of 6BIS Sendirian Berhad. Right. And the distinguished guests, ladies and gentlemen. Now I would like to begin my inaugural lectures today with the title Continual Learning with Neural Networks, Short Overview and Challenges. I started my career in 2011 in University of Malaya. Frankly speaking, this has been a wonderful, colorful, and productive journey for me. I have many people to thank, actually, which is not only listed here. This is only partially, right? First of all, I would like to thank my parents for their unconditional love, my siblings for their love and constant support. My sister is here today, right? Okay, with your presence, I feel very warm and motivated. Thanks to the University of Malaysia, where I have acquired valuable research knowledge and built my career. I feel very thankful to the top management team of University of Malaysia, especially to Vice Chancellor of UM, Dato' I.R. Rahim. To the management team of Faculty of Computer Science and Information Technology, especially the Dean, Professor Dr. Abriza Abdullah. Many thanks to my fellow colleagues and department members for your kind support and cooperation, and all the friends from industry for the great success of collaboration, and to all my students in my research lab who have put their commitments in the research. Without your contribution, I won't be able to achieve the success of all my research projects. Thank you very much. So this is a short overview of my career path from year 2004, after I obtained my PhD from USM, and I start my career in UM from the year 2011. So just now, I think Prof. Yasmin already briefed you about the career path, but so I will not further elaborate further here. I will straight away go to my today's topic. For the past 8 years, my basic research is focused on continual lifelong learning with neural networks and their application in neurorobotics, personalized healthcare, and wellness. I'm proud to say here the research output has been patented and commercialized through a UM spin-off company, which is UMCH Technology. So thank you very much again for the support of UM top management and especially UMCIC. A few weeks ago, IBM published an article about continual learning problems in neural networks research. In my opinion, this research topic is still relevant and important, which I think will trigger a new paradigm shift in AI technology. Everybody realize and know AI has gained a very great success in the past recent years. In 2017, this is the first time group DeepMind's AI techniques beat the world champion of Go players. So AI system indeed can outperform humans in chess, poker, and many other games. On the other hand, in year 2015, Microsoft team outperforms the humans on ImageNet large-scale facial recognition challenge. It is the first time AI system that outperform human in image recognition. Having said that, we also know that AI faced some challenge and limitation in recent years. From the picture, you can see that there are some accidents happen on the self-driving car in the year 2017 that involved the Uber self-driving car, and in the year 2016, during the test run of Google self-driving car. So what we can say about this, AI is very successful, but brittle in certain sense. If you want a regular automation with flexibility of human, regular of automation means free from human errors. There's not such AI technique are able to handle it yet. Right? Why? Because programming is frozen during execution time. And it can't handle malfunction in the circumstances beyond preparations. AI systems that operate in real-world environment are bound to fail at some point. The question is, how do we know when it will fail? it seems that it has no way that we can predict when it will fail. So this is the most dangerous part and very risky. Is there an easy solve problem for this or easy fix for it? Unfortunately, it's no. There are still a very long way to go to make the AI really practical for human. Two of the major problems that have been well acknowledged is first, catastrophic forgetting problem. And second is the practicality is constrained by expensive retraining. Why this happened? The main reason is human learn in a different way from machines. Human can learn continually in non-stationary environments where have to deal with non-stationary data. From childhood to adult to elderly, we are always learning and continuously. Whereas for machines, you always need a training phase and only can be trained with stationary data. This makes a very, very big difference, and which make the deviation of human intelligence from artificial intelligence. Okay, let's get an overall view what is artificial neural networks, because this is the main core technology behind the deep learning technology today. Artificial neural network is a brain-inspired computational model with different level of complexity, from the neuron level to the neural connection level and to the algorithmic level. Synapses is defined as a tiny gaps across neurons that relay chemical messages. So this is a very important part of biological neurons. And the ability of synapses to change or remodel themselves is called synaptic plasticity. Encoding a new long-term memory will involve the persistent changes in the number and the property of this kind of synapses. In other words, the intelligence of human brain comes from the changes of the synapses. This is where we encode our long-term memory also. So, artificial neural network has been trying to emulate the biological neuron in a more simplified way that it will involve the changes of the weight in the neural networks that we call it learning. So the modification of the weight actually represent and emulate the changes of synapses in the biological neuron. And it is a fact that humans learn continually. For example, we can learn the skill of playing chess, for example. And after learning the skill of playing chess, we can learn soccer, for example. So research has been shown that when we learn multiple skills in sequence, human animals does not suffer from catastrophic forgetting. The memory is still intact with us, even though we learn different skills in sequence. However, robot and machine behave differently. They suffer a problem we call catastrophic forgetting. When the robot learns a new skill, for example, playing chess, and learn the next skill like playing soccer, it will tend to forget the skill it have learned before. Why this happen? This is due to the nature of the artificial neural network we design. The artificial neural network learns skill by changing their neural connection weights. However, when we learn a new skill, it will lead to the rapid forgetting of the old skill because the same connections that encode the old skill had to be reused for the new skill. This is what we call catastrophic interference or catastrophic forgetting. It is still an unsolved problem nowadays, even in the AI research area. And how the human animal evolved to learn without catastrophic forgetting? So this has been my main research focus for the past 8 years. How do we learn stable memory? How our memory is first formed and then consolidated and maintained throughout our lifespan. This is a very fair question and difficult question in neuroscience. The typical human has 100 billion neurons and 60 trillion synapses. If you consider average of lifespan about 2 billion seconds in your life, and we assume that every very conservative estimation, each neuron fires every second with one spike. We are facing about 200 quadrillion spikes, which potentially modify a quintillion plastic synapses. You have any idea about quintillion? It's about power of 18, right? It's a very large number. So a natural question arises, how our memory is preserved despite all these regular changes happening in our brain. First, we can look at a beautiful example published by Young in 2009 in one of a very profound paper. He did an experiment, letting a rat running on a rotating rod. And what he found that he observed that the synapse of the motor cortex are modified, right? And even a new synapses are formed after the training. So this is called neuroplasticity. So human brain undergo a development process throughout the entire life with this neuroplasticity. At the beginning, when we are born, we are start with a lot of synapses with our brain, okay? And later, at the age of about 3 years old or below than that, a lot of synapses are starting to prune by development quickly, right? I mean, a lot of synapses are gone. Then the learning of novel experience causes the appearance of new synapses again, very quickly in a matter of days. However, some of them are lost again, but some are preserved as a permanent memory throughout the lifespan. So when we are aging, actually, we have encoded a lot of experience in a long-term memory. So in summary, we are having plastic synapses to learn new experience, but on the other hand, we have a stable brain to maintain long-term memory. How is it possible? Why the brain does not exhibit catastrophic forgetting? This is what we call stability plasticity dilemma. Okay. How our brain can magically resolve the stability plasticity dilemma? Then we have to refer to the neuroscience that have been studied throughout the past 20 years. There are a lot of new discovery that what they found is brain is massively a recurrent architecture. It is not a computation machine. Rather, it is a brain, is an embodiment of memory and algorithm at the same time. It's not like a von Neumann computer-based computer, which we have an external memory. We have a processor, and they are separate from each other. Our brain works in a very, very different way. For example, for vision, right? When our retina receives the vision signal from our retina, it will project to a component called lateral geniculate nucleus, LGN, on the thalamus. And from the thalamus, it projects to our visual cortex at the cerebral cortex. A very interesting finding is found here. While we are having a feed-forward projection from thalamus to visual cortex, in return, there are 10 times more feedback that back project to the thalamus, 10 times. This is a very interesting discovery. We may ask, what is this feedback for? So if you're interested, you can refer to the paper published in year 2008. A lot of detail described in the paper. Okay, let's do a thought experiment. Okay, imagine some of you in this afternoon decide to come to this talk and listen to my talk. Probably you are sitting on your desk in your room, then you decide to stand up, leave your desk, walk through a corridor, and come to this seminar room. All these are very straightforward because it's just a feed-forward planning. So from the discovery I mentioned just now, this much more feedback processing happen in your brain when you are doing all these tasks. So compared to feed-forward flow of information, at every moment you are matching your memory-based expectation with a sensory or other cortical input. For example, if somebody spray a perfume in the corridor, immediately you will sense the difference, right? Because it does not match with your expected experience. And maybe you will notice a new flower or new plant having here, right? This is a surprise to you because it does not match your expected experience. So these are the role of this all this feedback for in our brain. So what can we conclude about brain mechanism? At every moment, the brain predicts what it's about to see, hear, and feel. The brain is able to take small changes in the learned expectation. Neurons constantly learn a plastic change in their synapses. That's why you will notice difference later on. And the learning inputs and the expected to those inputs is the key to the cortical processing and intelligence. So what kind of brain mechanism can support this behavior? Are we able to use this essence of processing in the artificial intelligence system? My research is really greatly attributed to these two mentors of mine, Gail Carpenter and Stephen Grossberg from Boston University. They proposed a very beautiful theory and framework in 1987. It's called adaptive resonance theory that can explain how the brain resolves the stability plasticity dilemma. Their idea actually is further proven in 2008 by Massimiliano, reported in a very important paper that show a very strong neuroscience evidence that this ART framework is valid. They found that the brain magically resolves stability plasticity dilemma from the stable learning of bottom-up and top-down representation in the thalamocortical circuits. Okay, so what is the magic behind this? The basic intuition of ART or adaptive resonance theory is, in our brain there are three subsystems, namely the attentional subsystem, which provide the top-down expectation, and we have a learning subsystem, okay, which provide the bottom-up learning, like the projection from retina to thalamus, from thalamus to visual cortex. And this is a very important part, the orienting subsystem. So this system actually is the main component that decide when to switch stability to plasticity and when to switch from plasticity to stability during the learning. So what the system does is, the orienting subsystem will gauge how similar is your new experience compared to the expected memory in your long-term memory, expected knowledge in your long-term memory. If they are similar enough, then the system will trigger the sub-learning, the learning subsystem to learn the experience, to assimilate the experience. However, if the experience are mismatched, right, then it will shut down the learning subsystem and it will reset to find for a new matching from the attention subsystem. If it really couldn't find any match, then it will create a new synapse in your brain, a new connection in your brain. So for a novel experience, a new synapse will always be formed rather than changing the old synapse. So this is the key behind why catastrophic forgetting is not happen in human brain. So how can we model this in a computational way, right? Based on this theory. So we can abstract in a computation algorithm by having the three important components: the orienting subsystem, the learning subsystem, and the attentional subsystem in our algorithm. For example, we published a paper in 2018 by my PhD student, Dr. Naoki, on the kernel-based art map. You can see the color here. We have included three components in our algorithm: the comparison, which is the learning, the attentional, and the orienting in our system to resolve the stability plasticity dilemma and to allow continual learning in a lifelong continual learning without catastrophic forgetting. So you can see from this diagram simulation, you can see all these red dots are representing new synapses have been created during the learning process. And it is a one-shot learning, very fast, you don't need iteration. And this network have a lot of property that allow you to do continual learning. And later we extend this idea in 2019 by introducing topology formation. So this topology formation is very useful for navigation mapping for robots, for example, or when we do task planning for trajectory, right? So your automatics grow the neurons and synapses and form the neighborhood relationship. And it can adapt to different distribution because these data are non-stationary. It changes shape, for example, from slanting to a straight orientation. And yet the system, the network can adapt to the changes immediately. And we further apply the system in human-robot interaction that can use for gesture recognition, for object recognition, and face expression recognition. And in 2018, another PhD student, Dr. Farhan Daud, complete his PhD with a contribution of topological Gaussian art hidden Markov model. So we combine the idea of hidden Markov model with the ART architecture. So the robot can imitate the skill from the other robot, like by observing and automatically without retraining. And can perform a kind of self-learning through a mirror, just like our baby when he learn his own motor skill when they are very small. When looking at the mirror, he can imitate and explore his own capability, right, of affordance. And we apply we extend the art framework with the episodic memory, right, and semantic memory to perform the robot navigation planning to build the map automatically. And the map is encoded as a topological map as a long-term memory. So this work is attributed to Dr. Jin Wei Hong, one of my graduate students in 2018. Thank you. And many other applications like apply for blood pressure prediction, right, which is done by one of my good master student, Ms. Sundus, using the continual learning for the blood pressure prediction for healthcare application. And this is one of our recent research on the food recognition using diet cam, that the system can learn a new food every day, right, continuously without forgetting. So the diet cam can actually recommend a healthy diet by estimating how much is the calories, and recommend a diet plan. So in my lab, we have other application based on art technology, like metabolic syndrome diagnosis, which is Ms. Habiba, right? It's ongoing, the PhD. And Mr. Liu on the multiple time stack prediction for concept drift, multimodal emotion recognition, and so forth, and others. So I can give a quick summary on what we have done from 2011 to 2019. Thanks for the many funding agencies, including from University of Malaya, to make all this project a success. We get a various funds from UMLG, UM Grand Challenge, HIR, and so on. And from even international funding like NICOP from US, Sumitomo Foundation, and UAE. And we managed to develop many new algorithms and new applications. So the application are majorly from robotics, neurorobotics, and healthcare application for health analytics, right? And we managed to publish more than 50 papers out of this research. And one of the patents that we spin off is have been implemented in our healthcare platform under the spin-off technology UMCH. So we hope that to have a continual lifelong learning brain in every apps in future. So everybody can have your own personal brain, artificial brain, that can help you or complement your intelligence. So it's a matter of fact, our human brain, because of the natural process, aging process, our cognitive performance will keep on degrade exponentially when we are aging. Example, we will lose memory when we are aging. However, this technology could be possible to complement your lost energy, lost memory by learning what you experience. All right, so it's a good harmony of artificial intelligence and human intelligence that help each other. When you're aging, the AI become more intelligent, so the graph is opposite. Right, so we complement, help you, to maintain your life quality when you are aging. So what is the takeaway message, right? So the main problem is the stability, plasticity problem that we're trying to solve, because this is one of the major unsolved problems in AI nowadays. And we believe that art architecture provide a very efficient way to solve it, right? By introducing the three subsystems I mentioned just now, okay? The orienting subsystem, learning subsystem, and attentional subsystem in your algorithm. Having said that, there are many research by other researchers as well. They try to solve the same problem from different ways, right? From architectural level, from functional level, or from structural level. So we can consider all these techniques to further enhance the art approach. So this is the end of my talk. And if I have time, I want to show a demo.
What is on the table?
So this robot basically have zero knowledge.
I see a note on the table.
Right, it tried to learn a new object.
This is the bottle.
So what the robot learned,
Okay.
it tried to learn from the knowledge in the internet, from the cyberspace.
Now you see the system is crawling the images from the internet and tries to learn the bottle.
So it will perform the real-time feature extraction. At the same time, it creates a new neuron and synapses in the brain.
What is on the table?
I see bottle on the table.
Show me the cup.
I don't know what a cup is. Please teach me first.
This is the cup.
Okay, do you want the cup?
Then the robot will access to the internet and find the cup information. information and learn immediately, in real time. So you will see all kind of cut image and try to learn from the image.
What is on the table?
I see bottle and cup on the table.
What is on the table?
I see unknown, bottle, and cup on the table.
That is the bowl.
Okay, got it.
So at the
Show me
learning
the
program,
bowl.
a new neuron is created here to represent the bowl, which is encoded as a long-term memory.
Show me the bottle.
There is no bottle on the table. I don't know which one you mean.
This is the banana.
Okay, give a banana.
You still remember one of the episode in Matrix movie, right?
Show me the
actors
banana.
learn how to drive helicopter by downloading.
What is on the table?
I see bottle, banana, and cup on the table.
Show me the bottle.
I don't see any objects on the table.
Okay. So with this, I end my presentation. Thank you very much.
What is on the table?
I see a note on the table.
Sorry. Still there.
Thank you, Prof. Lu, for the highly insightful and I dare say very entertaining inaugural lecture. Another round of applause for Prof. Lu. Distinguished guests, I would like to call upon Professor Dr. Rofina Yasmin Osman to conclude the lecture which has been delivered by Professor Dr. Lu Kiong a moment ago.
Thank you very much. Thank you very much, Professor Lu Kiong, for the most interesting and insightful lecture. I really learned a lot about AI and the future of AI. And you know, Alhamdulillah, I'm glad I'm human, and I'm glad we're still ahead of the robots at this stage. But it is an exciting future, and as Prof. Lu has alluded, continual learning or lifelong learning represents an utterly interesting but challenging component of AI and autonomous agents operating in real-world data, which is typically non-stationary and temporally correlated. And the mammalian brain remains the best model for lifelong learning, which makes biology-inspired learning models a compelling approach. And as a biologist, I'm really happy about this link. It's what I believe all along. We really, biology-inspired research is really one of the, in fact, key areas for University of Malaya and the next strategic thrust of the university research. So it is a paradigm shift, and catastrophic forgetting is certainly a very exciting area of research. But you know, I hope that's not an excuse that FSKTM students use in exams. They got catastrophic forgetting. However, despite significant advances, current models of continual learning are still far from providing the flexibility, robustness, and scalability exhibited by biological systems. Continual learning has remained an open challenge in autonomous agents, and I'm very glad that University of Malaya is at the forefront of this research. Prof. Lu's lecture today shares about the research experience and challenges of continual learning with neural networks and its application in autonomous robotics and healthcare-related domain, including the diet cam. Very important for all of us in Malaysia after Hari Raya, especially. I think it's a wonderful new technology. Prof. Lu has highlighted a variety of neuro-robotic research studies that have been conducted at the Advanced Robotics Laboratory, ranging from adaptive resonance theory or ART, inspired continual learning, topological kernel-based ART, continual learning with kernel extreme learning machine or ELM, and their applications in autonomous robotics and healthcare domain. I believe from Prof. Lu's inaugural lecture today, we can see that this research has significantly contributed to the neuro-robotic research community and will be inspiring our understanding of the fundamental principles of continual learning and to produce a breakthrough in the field of autonomous robotics in the future. Of that, UM is very proud of you. With that, I just finished with a quote. Your talent determines what you can do. Your motivation determines how much you are willing to do. And your attitude determines how well you do it. And this is a great example of how to move forward. So with that, let us congratulate Prof. Dr. Lu Cho Kiong and his team for this excellent presentation and inaugural lecture. Thank you, Professor Lu.
Thank you, Professor Dr. Rofina Yasmin Osman, for chairing this lecture. I would like to take this opportunity to thank the management of the Faculty of Computer Science and IT, University of Malaya, distinguished guests, as well as everyone whom are here today for your time. With this, we have reached the end of the lecture. On behalf of the University of Malaya, I would like to apologize if there had been any shortcomings from our side in organizing this lecture. Refreshments will be served next door, just outside of this lecture hall. Ladies and gentlemen, once again, thank you and have a pleasant afternoon. Okay, so please be invited, the top management of the faculty, for a photo session with Prof. Dr. Lu Chu Kiong and also Prof. Dr. Rofina Yasmin Osman, as well as friends from the industry and families.